Alright, here we go. We now have a word problem that talks about real world situation. Domain of a real world situation may have to be limited in order to have reasonable answers. For instance, I'm never going to sell 1 million bottles of honey. So that wouldn't be a reasonable domain to me making money off my honey. Only non-negative numbers can be used to represent quantities such as time, no negative numbers, distance, no negative numbers, and number of people. Can't have negative people in a room. When both the domain and range of a function are limited to non-negative numbers, the function is graphed only in quadrant 1. Quick reminder, quadrant 1 is right here where both x and y are positive. The mid-Atlantic rib separates the North and South American plates from Eurasian and African plates. The function y equals 2.5x relates to the number of centimeters, y, the Mid-Atlantic ridge spreads after x years. That's interesting. Graph the function and use the graph to estimate how many centimeters the Mid-Atlantic ridge spread in 4.5 years. Okay, we can do that. The function, so they just gave it to us, all right. Y equals 2.5x determines how many centimeters the Mid-Atlantic ridge spread after, well, in this case, they have a variable in there, x years. Use only positive values of x and y. Use the graph to find the value of y when x is, it looks like 4.5. All right, so we can graph stuff. If I plug in a 0, 2.5 times 0 is 0 for the point 0, 0. I'm putting it right there. There we go. If I plug in 2, 2.5 times 2 is 5 for the point 2.5. Well, let's put that on here. 2.5 right there. If I go 4, 2.5 times 4 is 10 for the point 410. So let's go to 4. Looks like 10's right here. Now if I plug in 5, I get 12.5 for the point 5, 12.5, which should be right along, let's see, somewhere around here-ish. And then we can see that the graph goes like that. All right. We plot a point that represents the ordered pairs. Plot the points, which we did. Draw a line through all of the points, which we did, because the points appear to form a line, and they do. It's a linear equation, an equation that makes a line. Use a graph to estimate 4.5. Spreads about, well, 4.5, let's look at it. 4.5 about, well, that's 5, so 4.5 would be somewhere in here. Oh, looks like about, I don't know, 11, maybe a little more, 11.25 centimeters after 4.5 years. All right, distance of the distance of the Mid-Atlantic ridge spread increases. I guess it goes up as the number of years increase. So the graph is reasonable. It sure is. All right, when x is between 4 and 5, y is between, well, 4 and 5, 10 and 12, between 10 and 12, all right, or 10 and 12.5. Since 4.5 is between 4 and 5, it is reasonable to estimate y to be about 11.25, which is like right in the middle of 10 and 12.5 when x is 4.5. And there we have it. All right, we got one more. Let us do this one. Okay. So, a cruise ship. We have a cruise ship. Okay. It is currently 5 kilometers away from its port and is traveling away from the port at 15 kilometers per hour. Alright, so the function relates to the distance, right? 15x plus 5 starts 5 and 15 kilometers per hour, and that should be the y is the distance the ship will be from the port in x hours. Alright, how far will the cruise ship be from in 2.5? Well, let's do 0, 1, 2, 3. That shouldn't be too bad. Alright, so y is equal to 15 times 0 plus 5, which would be 5. So I have a point 0, 5. Let's put it on here. 0, 5. Alright. Now we got y is equal to 15 times my new x value of 1 plus 5, which equals 20. So I have a value of 120. You kind of see where this is going. It's just going to add 1 every 15 years every single time. So we got 120. Let's go ahead and do 2. Y is equal to 15 times 2 plus 5. That is going to equal, what, 35? So let's go 235 right there. And then y, let's put it here, 235. And y is equal to 15 times 3 plus 5. And that is 50. So we have another one that's 350. So we got 3 coming up here to 50. And I'm going to go ahead and make a line to the best of my ability without a graph, without a ruler. And here we go. We're going to estimate 2.5. So when x equals 2.5, y is approximately, squiggly lines for approximately. Let's find out. All right. So 2.5 is right about here, somewhere in there, right? I'm probably cheating a little bit because I'm doing a little math in my head, but it's about 42.5 kilometers, which is a reasonable answer between 35 and 50. All right, that's reasonable, and we're okay. All right, I'm probably going to give you an answer down here, and we're just going to do one more. Is it enough to plot 2 points? Generally, yes, but I want to say and no. All right. 2 can graph a line. But other functions, and we've seen some. We saw parabola on here, which you'll be graphing this year, require more points. And there it is. All right. When you use a graph to find the value of a function, do you always get an exact answer? No. Right? Sometimes the visual makes you guess. For instance, this one, you kind of have to guess. I don't know exactly where that is up here. All right. So you should always be close, though. All right. We could always plug in a point, obviously, to solve it. How do you graph a function that has all real numbers of the domain? All right. Well, choose. What do we do? Choose a few points. And graph using the shape determined by those points. And this isn't always easy. You may have to choose more points than you'd like to. I think we've got through this now. So I'm going to post these, and I think that's good for today. And we'll see you guys soon.